This video, we're going to talk about suggested homework problems from 10.3, parametric equations in calculus. Let's go ahead and get started with number 9. X is equal to 4t, y is equal to 3t minus 2, t is equal to 3. Take the derivative of x with respect to t, and we get 4. And the derivative of y with respect to t, and we get 3. So dy dx will be dy dt divided by dx dt is 3 over 4. To find the second derivative, d2y dx2, we'll take the derivative with respect to t of dy dx, that is a function of t, and divide it by dx dt. So that's going to be 0 over 4 is 0. So we're neither concave up nor concave down at this point. Just show you my instructions. I was supposed to find the first derivative and the second derivative and the slope, which we found, which was a positive 3/4 in the concavity, if possible. There was no concavity, and just make a statement about the concavity, whether it's concave up or concave down, based off of the information that we find. So let's look now at number 13. Thirteen says that x is equal to 4 cosine of theta, y is equal to 4 sine of theta. So our parameter here is theta, doesn't really change anything. Negative 4 sine of theta, dy d theta is 4 cosine of theta, dy dx is 4 sine theta, 4 cosine theta. This will be a negative cotangent of theta. And dy dx, when theta equals pi over 4, will be a negative 1. d2y dx2 is 4 sine theta at the bottom. Derivative at the top is cosecant squared theta. So that's going to be a negative 1 over 4 sine cubed theta. Evaluate that. Theta equals pi over 4. Get d2y dx2 when theta equals pi over 4 is equal to 1 over 4 times 1 over root 2 cubed. It's 1 over 4 times 1 over 2 root 2. So this 2 cancels and is 1 over 2 over root 2, which is 1 over root 2. Negative is a negative root 2 over 2. And that means that we are concave down at that point. And we have a negative slope in our concave downward, so we're on the right-hand side of the concave down piece. We're over here. Let's look now at number 15. X is equal to 2 plus secant theta y is equal to 1 plus 2 tan theta, and theta is equal to a negative pi over 3 dx d theta is equal to derivative secant is secant tangent dy d theta is 2 secant squared theta. So dy dx is secant theta tangent theta on the bottom, 2 secant squared theta on the top. One of the secants will cancel and give me 2 secant theta over tangent theta, which is 2 over cosine theta times cosine theta over sine theta. Dy dx is equal to 2 cosecant theta. And I want to evaluate that when theta is equal to negative pi over 3. So negative pi over 3. This is negative root 3. This is 1. This is 2. Cosecant is reciprocal of sine. So that's going to be equal to a negative 4 over root 3 times root 3 over root 3 is a negative 4 root 3 over 3. And my d2y dx2 is equal to the derivative of dy dx here, negative 2 cosecant cotangent divided by secant tangent is going to be cosine over sine is a cotangent, and a cotangent and a cotangent. So that's negative 2 cotangent cubed theta. And we'll evaluate that when theta is equal to negative pi over 3. So this is a negative 2 times, and then cotangent is adjacent over opposite. So negative 1 over root 3 to the third. d2y dx2 at theta is equal to negative pi over 3 is a negative 2 times a negative 1 over 3 root 3. This will be 2 over 3 root 3 times root 3 over root 3 is 2 root 3 over 9, which is positive and will be concave upward. Number 21. X is equal to t squared minus 4. Y is equal to t squared minus 2t. And then we're given the points 0, 0, negative 3, negative 1, and negative 3, 3. That we want to find the equation of the tangent line to the curve at each given point. So it would be helpful to find the t values associated with each of these points. T could be plus or minus 2 here for this one. But if I try negative 2, 4 plus 4 would not be 0. So this has to be t is equal to positive 2 here to get both coordinates to be 0. Let's see here. 1 minus 4 will give me 3, so t could be plus or minus 1. Let's see which it is here. This will be -1 will give me 1 plus 2 is 3, so that's -1, and this has to be +1. 1 minus 2 is -1. So those are my 3 t values that I need. Let's look for dx dt is 2t, dy dt is 2t minus 2. So dy dx in terms of t is 2t minus 2 over 2t, or that is dy dx is 1 minus 1 over t. So dy dx when t is equal to 2 is 1 minus 1/2 is 1/2. And the tangent line when t equals 1/2, we have a y-intercept there, so I can have y equals 1/2 x plus 0, so that one's pretty straightforward. Dy dx when t is equal to 1 is equal to 1 minus 1 is 0, so that will be a horizontal line. Y is equal to a -1. And then for dy dx, then t is equal to a -1. Then we have 1 plus 1 is 2, and y minus 3 is equal to 2 times x plus 3. Y minus 3 is equal to 2x plus 6. Y is equal to 2x plus 9. And I believe the book, for some reason, in all these cases, gets the form where all the x's and y's are on one side. It's all set equal to 0. I've solved for y in each of these cases, since that's what we're used to dealing with. So let's go ahead and let's look at number 29. Says x is equal to t squared minus t, y is equal to t cubed minus 3t minus 1. And I'd like to see, instructions are find the equation of the tangent line at the point where the curves cross itself. So you're really not going to be able to find this very easily by hand. I'm going to use the calculator to help me. X is equal to t. Oh, make sure you're in parametric mode, so mode, and change to parametric here. And when you go to y equals, it's going to give you an x1 of t and a y1 of t. So t squared minus t for x. Notice your variable changes when you hit the variable button here. T to the third minus 3t minus 1. And typically, if you zoom 6 in parametric mode, you're only going to see time starting at 0, and it's going to go out to 2 pi because it's used to t-values possibly being angles. I want to have the negative values here as well that correspond, so I'm going to make t start at negative 2 pi just so I can see this point where they cross right here. And I'm coming from this direction first and coming up, then going down and back up. If I were to watch it trace, I can do that here by see, making this like so. Still did it rather quickly. There it goes. That's how it should look when it's drawing it like that. All right, so I'm interested in this point that's right here. And I can't really tell the t values without tracing a little bit. And I'm taking very small steps that are like pi over 12 steps. So as I go to the right and advance t, it looks like I'm getting close to t equals -1 is possibly where that point is. So I'm going to trace. T is -1, and that looks like 2, 1 for my point of intersection. And then I'm going to keep advancing to see the next time that it crosses there. Looks like t is 2, so I'm going to confirm. And t is 2. It's also at 2, 1. So dy dx dt is 2t minus 1. dy dt is 3t squared minus 3. dy dx is 3t squared minus 3 over 2t minus 1. And dy dx when t equals -1 is 3 times 1 minus 3 over -2 minus 1. That's 0 over -3 is 0. And that does look like the horizontal tangent line to me. So my tangent line here is y is equal to 1. And then dy dx when t is equal to 2 is 3 times 4 minus 3 over 8 over 4 minus 1 is 9 over 3 is 3. So y minus 1 equals 3 times x minus 2. Y minus 1 equals 3x minus 6. And then y is equal to 3x minus 5. And that's my tangent line for the second point. And that's going in this direction here. Look at number 35. 35 tells us to find any places of horizontal and vertical tangency. So that's going to be where dy dt is equal to 0 will give us horizontal tangent lines, where dx dt equals 0 for vertical tangent lines. And we don't want both of them to be 0 at the same time, because that just means the curve isn't smooth there, and we get some kind of a cusp or something like that. So dx dt is equal to 1, dy dt is equal to 3t squared minus 12. So horizontal tangent when 3t squared minus 12 equals 0. 3t squared equals 12. T squared is equal to 4. T is equal to plus or minus 2. So at t equals -2, x is equal to 2. So -2 is equal to 2. Y of -2 is equal to -8 plus 24 plus 6. 30 minus 8 is 22. So y minus 22 is equal to I didn't find what that was yet. dy dx is 3t squared minus 12 over 1 is 3t squared minus 12. And this, when t is equal to a -2, is equal to 12 minus 12 is 0. I knew that because I'm finding where it's equal to 0. So this horizontal tangent line here will be at y equals to 22. At t is equal to 2, we have x of 2 is 6, and y of 2 is 8 minus 24 plus 6 is a -10. And that gives me a horizontal tangent line of y equals -10. We have no vertical tangent lines because dx dt can never be 0. So let's go ahead and let's verify this with the graphing calculator now. Clear all this out. T plus 4 for x, t to the third minus 12t plus 6, and zoom out a little bit. So these points that are up here, I want to second calc find dy dx when t is equal to -2. And that's going to be 0 at that point. And second calc dy dx when t is equal to 2. That's down here. We'll have horizontal tangent lines at both places that represent local extreme values. Let's go ahead and look at number 43. We want to determine concavity. X is equal to 3t squared. Y is equal to t cubed minus t. So dx dt is 6t, dy dt is 3t squared minus 1, dy dx is 3t squared minus 1 over 6t is 1/2 t minus 1/6 t to the negative first. Dy d2y dx2 is derivative with respect to t of 1/2 t minus 1/6 t to the negative first over 6t will be 1/2 plus 1/6 t to the negative second over 6t, going to multiply by 6t to the second over 6t to the second, and d2y dx2 is equal to 3t squared plus 1 over 36t to the third. Now I want to look at my second derivative test here. So 3t squared plus 1 is never 0, but 36t squared has a 0 of 0. And so to the left of 0, I'm going to have a positive over a negative, and this is going to be concave down. And to the right, this is going to be a positive over a positive and will be concave up. At 0, I'm neither concave up nor concave down, so my intervals here are open. Concave down from negative infinity to 0, and concave up from 0 to infinity. I could also express this as being concave down when t is less than 0, and concave up when t is greater than 0, and neither concave up nor concave down when t is equal to 0. Let's go ahead now and look at number 49. One of the times that we're going to really like to parameterize things is when it comes to arc length. So we have a nice formula that says that our arc length now is from t1 to t2 square root of dx dt squared plus dy dt squared dt. So if I have x is equal to 3t plus 5, dx dt is equal to 3, y is equal to 7 minus 2t, dy dt is equal to a negative 2. And my interval here for t is that t is between negative 1 and 3. So s is from negative 1 to 3, an integral of square root of 3 squared plus negative 2 squared, all under the square root sign dt, is integral from negative 1 to 3 of the square root of 9 plus 4 is 13 dt. So this is root 13, and then integral of dt is t, and t gets evaluated from -1 to 3 is root 13 times 3 plus 1 is 4 root 13. 4 root 13 is approximately 14.422. Let's go ahead and look at number 51 now. '51 says x is equal to e to the negative t cosine of t, and y is equal to e to the negative t sine of t, and 0 less than or equal to t less than or equal to pi over 2. Dx dt is going to be a negative e to the negative t cosine of t minus e to the negative t sine of t, and dy dt is a negative e to the negative t sine of t plus e to the negative t cosine of t. Each of those involves a product rule. And then if I have dx dt squared, that's going to be e to the negative 2t cosine squared t plus 2e to the negative t sine t cosine t plus e to the negative 2t sine squared t, and dy dt quantity squared is e to the negative 2t sine squared t plus a negative 2e to the negative t sine t cosine of t plus e to the negative 2t cosine squared t. So when I add these together, these zero each other out, and this makes e to the negative 2t times 1 plus another e to the negative 2t times 1 and I have 2e to the negative 2t. So that's what's underneath my square root sign. S is from 0 to pi over 2. Square root of 2e to the negative 2t dt. So that is root 2, integral 0 to pi over 2, e to the negative t dt. S is equal to a negative root 2 times e to the negative t from 0 to pi over 2 is a negative root 2 times e to the negative pi over 2 minus 1, and this is the same as root 2 times 1 minus e to the negative pi over 2, which is approximately square root of 2 times 1 minus e to the negative pi over 2, 1.12 is sufficient for the book there. Let's finish up with number 65. 65 says x is equal to 5 cosine of theta, y is equal to 5 sine of theta. Theta is between 0 and pi over 2, and we want to revolve around the y-axis here, and we want the surface area of this. So our formula is capital S is equal to 2 pi, integral from lower bound to upper bound of our x of t, which is 5 cosine of theta, times the square root of dx dt squared. So that's going to be 25 sine squared theta, and this is going to be 5 cosine theta. So when I square that, that is 25 cosine squared theta d theta. So 2 and 5 make 10 pi, integral of 0 to pi over 2 cosine theta. This is square root of 25 cosine squared theta plus sine squared theta d theta. All that's a 1. Square root of 25 is 5. So pull that 5 out now and make 50 pi, integral of 0 to pi over 2 cosine of theta d theta will be 50 pi sine of theta from 0 to pi over 2 is going to be capital S is 50 pi, and then sine of pi over 2 is 1, sine of 0 is 0. So this is exactly 50 pi square units. And if you want an approximation for that, (157.080) square units. There we go. That's it for this video. We'll come back next time and talk about 10.4, which is polar coordinates and polar graphing. See you for the next video.